Today we're going to be covering two sections, so sit back, make sure you have all your supplies and maybe a snack. For today's video, we've got two sections, 11.3 multiplying rational expressions and 11.4 dividing rational expressions. The main idea today will be to divide and of course multiply rational expressions and use dimensional analysis with multiplying and dividing. Many of you may recall dimensional analysis from science. This is standard 13.0. So as we start today, I just wanted to kind of take you back a couple of years, back to fractions. Do you remember multiplying two fractions like this? How did you do it when maybe it was 5th grade or 6th grade that you remember multiplying your fractions? How did you do this? So if you take a look, probably back in 5th grade, maybe even 4th for some of you, you remember that multiplying fractions like 3/4 times 12 over 15, you can do some cross-canceling. So we can say, hey, 4 can go into 12 3 times, so we cross it out and write the 3. 4 can go into itself 1 time. And we can do the same thing for 3 and 15. 3 can go into 3 once, 3 can go into 15 5 times. And then you remember that we went straight across and we multiplied and we got 3/5. Okay? So today we're going to take this problem to another level with polynomials. Okay? Also back in maybe 3rd, 4th, 5th, 6th grade, do you remember dividing your fractions? How did you do that back then? You remember taking 3/4 and repeating the rule to remember to multiply by the reciprocal. We multiplied by the reciprocal, which is 20 over 6. And then we can do the same canceling. So 3 can go into 3 once, 3 can go into 6 2 times. 4 can go into 4 once, 4 can go into 25 times. And then you simplified, you went straight across, and you would get 5 halves. And we're going to actually leave our answers in improper form. Okay? So you remember doing those problems like that? Today, we're going to put a spin on it, okay? What we're going to do today, and I'm going to give you a quick preview on it, is we're going to take these problems but complete them in a different way. So, we're going to add in some factoring, okay? So, for example, we can actually do factoring even with our regular fractions like this. This is how we used to do it. Today, we're going to add in the factoring component. So, what that means is, instead of writing 3/4 times 12/15, I'm going to factor whatever I can. So if I take a look, 3 is prime, I'm going to leave 3 alone. 4 can be factored. What is 4? Did anyone say 2 times 2? 2 times 2. So since 2 times 2 is 4, I'm going to replace it and cross that out. Okay? What is 12? Well, 12 is 6 times 2, but 6 is not prime. 6 is 2 times 3. So I can replace this with 2 times 2 times 3, which is 6 times 2. And 15, we can factor that to 3 times 5. So after you factor this, we're going to take this fraction bar and we're going to extend it all the way. And this becomes one whole fraction. It'll be 3 times 2 times 2 times 3. 2 times 2 times 3 times 5, and now we're going to do what we did yesterday and simplify our expression. Now it's just one fraction. What can I simplify? Remember, you can only simplify one from the top and one from the bottom. So 3 and 3 can cancel out, 2 and 2 can cancel out, and the other 2 and 2 can cancel out. So when I finish collecting all my like terms, I have 3 times 1 times 1 times 1, so that's 3. 1 times 1 times 1 times 5, I get 5. And take a look. Don't I have the same answer as what I had before? Now the beauty in this is, today you won't have numbers. That's why we're going to have to do it by factoring. Some of you are probably saying, but I can just multiply and cancel, can't I? Well, stay tuned. Okay? So we can do the same thing with the division problem. We rewrote that division problem as 3/4 times the reciprocal 20 over 6. We're going to do the same thing and factor it. So I'm going to factor 4 is 2 times 2, so I'm going to replace the 4. 20 is 2 times 10, which is 2 times 2 times 5. 6 is 2 times 3. And once I have everything factored, I'm going to extend the fraction bar And now this becomes one big fraction. 3 times 2 times 2 times 5 over 2 times 2 times 2 times 3. What can we cancel? Cancel out my 2's, cancel out another 2, cancel out a 3. What do I have left? I have 5 over 2. And ta-da, it's the same answer as the other one. Okay? So today we're just going to use a factoring method. Okay? So let's go ahead and get started. And these are the steps that we're going to be following. So step number 1. To multiply rationals, okay, multiplying rationals, first thing we're going to do is exactly like I did in the examples, we're going to factor completely. Okay, so if you have a polynomial, you'll have to factor all the way, okay, including those dots again. If you have a number that's a composite number, factor it down to its prime, the prime components. Number 2, after you finish factoring all the way, extend that fraction bar. Make one big fraction. Step number 3, we're going to cancel out the common factors from the top and bottom. Remember, this has to be done so that 1 on the top cancels 1 on the bottom each time. Okay? And then step number 4, after we finish canceling, we've got to do our cleanup, and we're going to clean everything up, simplify. Collect the remaining factors across the top and across the bottom. Okay, so with those steps, let's go ahead and give one a try that actually has polynomials in it. Okay, so example number 1. Okay, example number 1, we're going to go ahead and multiply this binomial over binomial times a trinomial over a trinomial. Okay, so give yourself a moment, pause as you need to copy down the problem. Okay, let's go ahead and now simplify. Remember what step 1 said, we had to factor all the way. So what I'm going to go ahead and do is start factoring this. Okay, so I've got b plus 3 over 4b minus 12 times a b squared minus 4b plus 3 over b squared minus 7b minus 30. Okay, so let's start factoring. Okay, b plus 3 I think is completely factored. I'm just going to wrap it up. b plus 3 is its own binomial. 4b minus 12, I think we can take out a GCF of 4. So 4, I'm going to take out 4 times b minus 3. So this can be replaced with b minus 3. And if you'd like to, you can take that 4 and replace it with a 2 times 2. Okay? And then that b squared minus 4b plus 3, it's a trinomial. It does not have a GCF factor. So we're going to go ahead and start checking. Is the first a square, is the last a square? Not a PST. So then I go to X box. So I'm going to go ahead and do my X, or for many of you, those of you who know the shortcut, since it's a special case, because it's 1b squared, I can do a short diamond on this. So I have a product of 3, and negative 4 is my sum. So I've got negative 3, negative 1. So this factors out to b minus 3 times a b minus 1. Okay, replaced it, going to cross that out. Okay, and then on the bottom, on this one, another short diamond, because it's a 1, leading coefficient of 1, and I have a product of negative 30 with a sum of negative 7. So brainstorming now, I've got 3 and 10, 10 and 3 with a negative on my 10. So this is b minus 10 times b plus 3, and that cancels this one out. Okay, so now everything is factored. You can choose to rewrite it. If you're one of the people that, likes their paper super neat, you can go ahead and rewrite it, or you can go ahead and start simplifying now and then rewrite when you're done. Okay, I'm going to go ahead and go to step 2. After everything's completely factored, step 2 says extend that fraction bar all the way across. Okay, so now these are my 3 factors on the top: b plus 3, b minus 3, b minus 1. On the bottom, I have 2 times 2, b minus 3 times b minus 10, b plus 3. Are there any factors that cancel out completely? Keep in mind, we cannot cancel if they're wrapped up in parentheses, because you have to cancel the entire amount. You can't just cancel the b or the 3. Okay? They cannot be separated. Think of them as chained together by that plus or minus sign. These are chained together. You cannot separate them. Okay? So which bubbles, okay, okay, which wrapped up pieces can I cancel? Well, if you take a look, I've got a b plus 3 here, and it's the same as this b plus 3 down here. So I can cancel out these two bubbles. Okay. Any other factors that you see are the same? I see a b minus 3 and another b minus 3. So I'm going to go ahead and cancel these guys out. Okay. And then I don't see any other ones that are the same. I have b minus 1 and a b minus 10. Remember again, you cannot cancel that b with that b. These are chained together. These are chained together. They're in that bubble. Okay? So since I'm done, I'm just going to go straight across and simplify. On the top, I have a b minus 3. So I'm going to go ahead and write that here. b minus 1 is left on the top. And then on the bottom, I have a 2 times 2, which is 4. 4 times a b minus 10 is still down here. 4 times b minus 10. And that would be my answer. Okay? Because these cannot be simplified any further. Okay? So, in today's lesson, we are not stating any excluded values, so you would actually just simplify and stop here. So this would be the full example. Okay? Okay, so it's your turn now. Go ahead and try. This is in your workbook. Okay, I want you to try your turn. Try workbook, page 141, problem number 9. Okay, go ahead and give that a try. You can pause here as needed. Okay. Moving on. Okay, we've just completed this example and you had your try problem. We're going to go ahead and move on to the next portion. Okay. Next thing is in the multiplication section, we also have something called dimensional analysis. Now, dimensional analysis you may have heard of from science, okay? And all that is breaking down the measurements, okay? Measurements to convert them from one unit of measure to another. And very important piece here is that the unit of measurement is very key here, okay? Unit of measure is key. So we have to make sure you take a look at the unit of measure. That's going to be very important, okay? So we're going to go ahead and do an example from this one, okay? And before we do, just want to make sure the steps for this one. We're going to create, number 1, create equivalent fractions using conversion facts. Be sure you write the units this time. If you don't write the units down, you will be unable to do the conversion. So make sure you write the units. It's very important, okay? Step number 2, you're going to position your fractions so that the units will cancel out, and then you're left with the units you want. Okay? So let's go ahead and give this a try. Okay? Here is an example. Okay, example number 2. I have 4 hours and I need to convert it into seconds. Now for many of you, you could probably do this in your head. We understand that. But I picked an easy example to show you how dimensional analysis works. Okay? Now, if you don't know any of your units of measure or you forgot some of them, you can check in the back of your math textbook for more conversion facts. Okay? Now, this is how we would set this problem up. Since 4 hours is what I need to convert, I need to make sure at the end I have seconds. Okay? So to do that, 4 hours, how many hours and how many minutes? Do I have a conversion fact for that? We know that we have 1 hour gives us 60 minutes. Okay? Notice where I positioned it. The hours are on the bottom with the hours because eventually they will cancel out. Okay? Then I need to take my minutes to convert them into seconds. So what do I know about minutes and seconds? I know that 1 minute is 60 seconds. And I also positioned this so that the minutes will cancel out. Now, once all of those cancel out, I am left with exactly what I want. And that would be the seconds are left over. Okay? So I would have 4 hours, which HRS, times 60 minutes over 1 hour, times 60 seconds over 1 minute. The hour cancels with the hours. The minutes cancels with the minutes. It's exactly what we want. So the first thing is to check your units. Make sure they will cancel out and give you what you want. You want seconds. So now we know our answer will be in seconds. Okay? And then finally we need to multiply or divide whatever we have remaining here. Now if you notice, I'm going to extend my fraction bar here. I've got 4 times 60 times 60. Okay? So I'm going to go ahead and do a quick calculation. 60 times 4 will give me 240. Then I'm going to go ahead and multiply this by 60 again. So that gives me, that's 24, that's 214,400. So I get 400 seconds. Sorry, 14,400 seconds. Okay? So that'll give me 14,400 seconds. Okay? And what does that mean? That's how many will be in 4 hours. Okay? So your turn. Okay? Go ahead and try. Okay? Try in the workbook again. Try workbook page 142, problem number 2. Okay? Pause here as you try the problem. Okay. Now, moving on, we're now going into our next section. Remember that we said today we have 2 sections, okay? So this is now the dividing rationals, okay? And this is chapter 11, section 4. This is the next section. This is where it begins, okay? Now, as you recall, back at the beginning, we had you think about how you divided regular fractions, okay? Remember back to our opening page. We did multiplying, we did dividing. The difference was in multiplying, you could just start canceling away and then simplify. Dividing had one extra step. Do you remember what that extra step was? Remember the reciprocal? And that's where it comes in, okay? So these are the steps on dividing rationals, okay? So to divide rationals, the first thing you need to do is change your division to multiplication by the reciprocal, okay? So change division to multiplication of the reciprocal. Then, after that, it's all the same as multiplying, and that's why we put this section together with the multiplying today, because they're really, in essence, the same thing, okay? Step 2, you're going to factor completely, all from multiplying, okay? You're going to extend your fraction bar. You're going to cancel out your top and bottom, the common factors. And, of course, the last thing is to collect your remaining terms across the top and bottom. Now you'll notice all of this, steps 2, 3, 4, and 5, are the same as multiplication. The only thing is we're adding one extra step, and that would be the reciprocal step. Multiplied by the reciprocal is the big step that we must do for dividing. Okay? So let us go ahead and give this a try right now. Okay? So this is now example number 3. Okay? We're going to go ahead and do a division. Go ahead and copy down the problem. I've got 6b plus 12 over 9 minus b squared divided by b squared minus 4 over b squared minus 5b plus 6. Okay? And we're going to go ahead and try this right now. Okay? Example. Again, this is example number 3. Okay? So, remember what the steps were. Step 1, I've got to change it. So that's the first thing I'm going to do. Rewrite this as 6b plus 12 over 9 minus b squared times the reciprocal, so flip this around, b squared minus 5b plus 6 over b squared minus 4. That's step 1. Step 2, I'm going to go ahead and completely factor this. So take a look. 6b plus 12, you notice that there's a GCF of 6 here. I'm going to replace it with 6 times the quantity b plus 2. So cross that out because I've replaced it. I notice I have a dots right here. This is a 3 squared minus a b squared. So this becomes 3 plus b and a 3 minus b. So I've replaced this one. Cross that one out. Then I come over here. I notice I have another dots. So this is b squared minus 2 squared. So this becomes b plus 2, b minus 2. Crossing that one out because I'm replacing it. And then up on top, let's see, there's no GCF, and 6 is not a square, so this is not going to be a PST. So I'm going to go ahead and quickly do a diamond for this because this is short. I notice this is a 1b squared. So I have a product of 6 and a negative 5 as my sum, which gives me negative 2 and negative 3 will work, right? So this is now b minus 2 times b minus 3. Okay, and I'm going to cross this one out. So notice everything has been replaced. I'm going to extend my fraction bar. Now, if you do feel this is too messy for you, you can rewrite it. I'll go ahead and do that right now. 6 you could rewrite if you want to as 2 times 3. You don't have to. Okay. B plus 2 is on the top times a b minus 2 times a b minus 3. Across the top and on the bottom, my denominator, I have a 3 plus b, a 3 minus b, times b plus 2 and a b minus 2. Now this is the fun part. Okay, now I get to do all my canceling. So do you see anything you can cancel right now? I see a b plus 2. Do you? You can cancel that b plus 2. Remember, they have to stay in that bubble. It has to be that entire bubble. B plus 2, b plus 2. Canceling that. Anything else you see the same? I have a b minus 2 and a b minus 2. Let's cancel that one out. Okay. Let's see. I have a b minus 3. It's kind of close to my 3 minus b. Don't they kind of look close to each other? Is there a way to change it so they do exactly match? Well, if you think about it, if I use the commutative property on this, let's say I wanted to change it so they match each other. Okay, I'm going to go ahead and let's say I change the top one. Okay, b minus 3. Could I change it if I use commutative and just switch it? Wouldn't it be negative 3 plus b? It kind of looks like 3 minus b. It's getting closer. Okay, and that is actually okay because these are exactly the same. Okay, it's just the order is different. Commutative property again. Now, the only difference now is if you take a look at the signs. This is a negative 3, this is a positive 3. This is a positive b, this is a negative b. You notice they're only off by a negative? Could I factor out a GCF of negative 1? If I divided this by negative 1, I would get a positive 3. If I divided this one by negative 1, I would get a negative b. And I would replace negative 3 plus b with a negative 1 times a 3 minus b. That would actually replace this. Now if I do that, do I have common factors again? Is 3 minus b the same as 3 minus b? They are the same. Now I can cancel that one out. So beware, if you need to replay that one, go ahead and replay it. You can factor out a negative 1 to change the signs on each of your terms, okay, within a binomial factor, okay? So now I've canceled everything. I'm going to go ahead and clean house here, go straight across. 2 times 3 is 6. 6 times negative 1 gives me a negative 6 over 3 plus b, no other factors here, this is a 1, 1, 1, so this can be rewritten as a 3 plus b. Now you can also write, couldn't I also write a negative 6 over a b plus 3, commutative property? I could do that too. So either of these answers are acceptable. Okay? Okay, so now it's your turn to try. Okay? So your turn in your workbook on page 143, problem number 11. Okay? Go ahead and give that one a try. Okay, now we're moving on to our last piece today. Okay, our last piece is dimensional analysis in our division section. Okay, so here is an example that we're going to go ahead and do. Okay, and there is a little reminder on the side. Beware of your units. Notice that m cubed cannot cancel completely, okay, with a regular m meters. Okay, so we have to be very careful on this one. Okay, so if I have this, okay, let's say I have 35/100 meters cubed, okay? Eventually I need to make it all the way down to centimeters cubed, okay? That's what my conversion is. I need to get that all the way there. Now, do we know any facts about meters and centimeters? Well, I know one piece of information. I know that 1 meter is the same as 100 centimeters, okay? So if I know that fact, is there any way I can rewrite it as a fraction? Okay, so I can set it up for canceling. Remember, meters cubed just means meters times meters times meters, right? It's the same thing, okay? So I need my meters on the bottom, so they'll cancel with one of the meters here, okay? So I'm going to put 1 meter on the bottom and 100 centimeters on top. Now if you take a look, I have meters cubed, which means I have 3 of them. So that means I'm going to need 3 of these m's to cancel with those 3 m's, which means, yes, you are right, I'm going to need 3 of these. Okay, and by doing that, I have meters. This meters will cancel with one of these meters. This meter will cancel with the other one, and this meter will cancel with that one. In other words, meters times meters times meters is meters cubed, so I've canceled it, okay? So now all of this is canceled. What do I have remaining? I have 35 hundredths times 100 times 100 times 100, and notice I have centimeters times centimeters times centimeters, which gives us centimeters cubed. And that's exactly what we wanted. We wanted centimeters cubed, okay? So now I just need to do my multiplication, and those of you who may recall this from elementary school, there was a trick with multiplying by powers of 10. If I multiply by 100, I move my decimal 2 places. Okay, 100, 2 more places, and 2 more places. So if I have this and I'm multiplying by 100, 100, okay, this is my second 100, and then my third 100. I've moved it 2 places for this one, 2 places for this one, and 2 places for this one. I moved it 6 places total. So now I'm going to fill in with my zeros here. So what is my answer then? I've got 1, 2, 3, 4 zeros. So 35 hundredths meters cubed will actually equal 350,000 centimeters cubed. And that would be my final answer. Okay, so it's your turn. Go ahead and try in your workbook, again, on page 144, problem number 10. Okay, and bring the 4 problems to class tomorrow. See you then. Bye.